carbon already the gold already peel off a lot. Okay, let's talking about how to get a good image, how to do the focusing, and do the stimulation or adjust the aperture kind of stuff. And you see the image now is very blurred, not clear, because we are not really in a fixed condition. And so the first thing that you're thinking about is to adjust the focusing level here. So you try to focus it. You write the image rather than become focusing. It's either changing the shape in this direction, while you want to focus in the other direction, then you will have some distortion in the other angle. So that is because you having a stimulation at your image. So you need to correct the stimulation by adjust the two level here. How you do that? You first try to focus your image in. Okay, your imaging may be not clear, but you make sure there's no major distortion of your image. Okay, then you using the stigmator to correct it. Correct one direction always first, then correct the other direction until the image getting clear. Okay. So you repeat this step by zooming so this is the one we call the stimulation correction adjustment.
So how much the recommended mag that you use to video? What's the recommended magnification?
Recommended magnification. There is no recommended magnification to do anything, but it's more like how you get a good or nice image is always start from low magnification because easy adjustment. Then you go to higher magnification to have a fine or more accurate adjustment. Then until you get close to the magnification that you want. Yeah. So this is one thing, the stimulation. But how to get a good image is you still need to adjust your aperture position correct. So that's why we call the wobbling. How you do that? You go to the aperture. You say focus over. Click it. Your imaging is kind of like shaking, but you don't see that the movement clear because your scan speed is very slow. I will go to scan speed 1. Then I see my image is moving. This is very critical to get a nice image because a whole optical beam system is that the electron is leaving the source, then it goes to few lengths, then finally it reaches the sample. So if your system and the aperture is placed in between the condenser lens and the objective lens. So if anything inside is not really perpendicular or aligned between these optical beam paths, then you have a problem for focusing. Yeah. So what we are doing now, although we do wobble, but we actually changing the acceleration voltage a bit. And as apply now the acceleration voltage is 10 kV. So the system now is fluctuation the acceleration voltage maybe by 0.some%. So if your optical beam path now is not aligned properly, you will see this movement because by changing the EST. So they're using this method to correct the beam path, or the aperture position adjustment. Okay, so what's this?
Yes.
Oh, yeah. So you see the imaging is now moving up and down. So while over here I have the aperture position. For this is the aperture strip. I have 3 holes of there. What you can see 2 of here, the aperture. You see the aperture 1. This is aperture 2. With the aperture 1 also. And you actually can see the data. Aperture 1, aperture 2. So this will tell you about the diameter and the actual position. So there will be still tiny adjustment that you have to do to get the best, to get a good image. So normally I was using aperture 30 to give you good how would I say current. Well, aperture 20 you may have a better imaging, but the signal to noise ratio won't be that good because not many current coming down. Okay, so I need to adjust the imaging and clear so that it won't go into moving a lot. If you see that it's moving up and down, you correct the Y. This is the Y direction. Okay, this is the Y. You correct the Y. Now you have some X come out. Because actually, it's not that you correct the Y, then you have the X come out. It's more like just now the X is not that visible because of the Y. So then you correct the X. They have the Y. You see this is the wobble amplitude. You see how big the movement will happen. I don't go so. Normally I say something like 10, which is quite reasonable. So you adjust them correctly. The imaging shouldn't move. It should stay like a heartbeat. You should. Like heart is beating. Yeah. So then the mobile adjustment is okay. Then you go back and do the focusing, segmentation adjustment. Repeat all the process. You have a really high high EMI or something like. You see the nucleus? Yeah. How is the site condition here?
Rubbish.
Oh.
Unfortunately, you see, all of the power for the whole building goes over that roof.
Wow.
So
That's terrible. So you see that then you go to even higher magnification, you will be limited by your image quality will be limited by that reports. Yeah. So, but if you go that not that high magnification, of course you don't see that obvious. Yeah. So I mean, how we do the one is that you always remember, you get a sample. The first thing, of course, is thinking is that you do a focus. Then, during the one you do focusing, you realize your imaging is changing a shape, elongating in some direction. Then, you correct the stigmation. But remember, correct in one direction first until the image is good. Then correct in the y direction. So, then you go to trying to do focus. And if you realize that your imaging is still moving, which means your aperture is not in the center, so you do a wobbling. But do a wobbling by adjust the aperture position of the X to correct the movement in this direction, in the left and right. While the Y is to correct the movement up and down until you have something more like a heartbeating. Then you disturb the wobble, go back and do the focusing again and stimulation correction. So that is the right way you can get a good image. Okay, a good image is not only focusing, but it's also how you do let's say the brightness and contrast. This is not a good image because it's too bright. So how you justify a good image is a good image. The brightness contrast is suitable. You go to the scan. Go to a faster scan speed. There's something called night scan. You see, this is representing my SCM now is scanning along this particular line. Now this one is representing the signal that I'm getting for this line. The image we are getting is a gray color one. So they have 255 gray level. So all my image now all move to the upper part, and they all hit the saturation limit. So that's why the image are all very bright. You need to adjust the contrast, brightness, let them get back to the within this 255 gray level region. Then you disable the night scan. This is more or less something like a good image quality, the brightness and contrast. And let's go back to this one again. At brightness over here, you adjust the brightness, you will move the whole peak up and down. The contrast, you need to amplify all the peaks. So that's just something you have to know, what the difference between brightness and the contrast. I mean, of course, there is a guideline. Different people, I may prefer a brighter image. I may prefer a slightly darker image. But the main concept is that You don't want your image too bright or too dark, so that you will have some hidden information, or information that is all covered by the darkness or brightness. So that is a key point here. And this is still not a good image because it's too noisy. A good image that is just too noisy. So you need to use certain we call the noise reduction technique. Is under the scanning. During focusing, that we normally using the pixel average and a certain scan speed so that you can differentiate. Because it's easy, it's only integrate this particular pixel position, so it can easily allow you to do focusing and certain fast refreshing time. We also have the one we call the 9 average. So you can change, you can decide how many the n number that you want. 60. Then scan speed. You see, this is the whole cycle time. It will tell you how long it's going to image the whole, scanning the whole area. 1.3 minutes is a bit long. So I will reduce the scan speed, for example, to 3. Yeah, 20 seconds is reasonable. So you will have a reasonable image, the signal to noise ratio from your image. Then you will click freeze. The image will freeze after the 21 second scanning. Okay. So, you finish the scan, then you want to save the image. You just right click on the screen. Send to. You can save as a TIFF file, bitmap file, JPEG file. But I suggest to save TIFF file because it has most of the function. No, the information. So you save as TIFF. Now you pop up to all the image directory. Normally I will always prefer save all the image in the D drive. So you can create your username, your own folder, or maybe I just put a training. Up here, you give a name of your file. You can put the digital number, how many the digital number you will go after this file name. So the next time you save, this number will automatically increase. It becomes 01, 02, 03. And over here, you can choose whether you want to merge this kind of annotation in your image, or you just want to have a plain image, nothing. Normally, yeah, we will say yes. And whether you want to save a color mode, so which means the annotation that you go in here is going to be color or plain white. Then you set the color merge. You'll save the image. So there is an image